don't worry if you, I mean, feel free to write if you are, feel free to write your question in case you are afraid, like shy to speak out. Okay, so a little bit of history first. How C# came to be. Um, I actually was working with C# since 1.0, since the beginning of it, and it's actually kind of fun to see the evolution of it up until they started to integrate all the functional programming stuff, which I'm on the edge of it, but this is my personal opinion, which this is like discussable things. But in any case, so before C#, we were having Java, right? And Java is the same, is similar, it's very similar to C# in terms of how it actually works, how it functions. Back then, Java was owned by Sun Microsystems, and anything, almost all machines, like almost all, um, like all computers, like so the Mac and Windows and probably other platforms, they were actually able to run Java code, right? So Java has this runtime in it, where we can like similar to the C# runtime, which I think Dennis already talked to you about, and I'm going to reiterate over it here as well. But in any case, what happened was, because Java was actually open source, or rather actually an open standard, there were two runtimes actually were made. One of them is from Sun Microsystems, and the other one was from Microsoft. And the fun part was, if you actually install an application, there is a very good chance that it will ask you to, back then in the early 90s, it will ask you to say, aha, okay, please install Microsoft Runtime. Now, because Java was open, and everybody could like, modify things, and actually Microsoft came up with its own runtime and things like that. It bothered some microsystems very much, and they were actually quite, I would say, like they were fighting Microsoft a lot in terms of that part, like stop messing with the programming language, please, or stop adding this and that. This is not how we want it, and so on and so forth. And the licenses, of course, and all that license fights. Then Microsoft said, aha, okay, this actually like kind of troublesome, fighting against like trying to get the Java to work, and then you are actually like fighting with the owners and stuff like that. So they simply said, okay, we're gonna make our own programming language, which is quite similar, in fact, to Java. And so they made C# because in the musical notes and musical theory, the note after C is actually C#. So so they actually like said, I think at the beginning it was called the Project Neat, and I think like two or three people were starting to work on it, and they actually like they made just the initial seed of the language, and then the rest it was history. So it was like what, 2000? I think in the year 2000 we have seen the first version of C#. I think I really cannot recall anymore right now which year exactly. So excuse me, just hang on. All righty. Sorry. So where were we? So actually, like um, we were at so actually like people made the C#. C# 1.0 was released with the first edition of Visual Studio.net, and it was called actually Visual Studio.net, because back then there was actually Visual Studio, and just Visual Studio where people, developers in C++ and probably other languages were using it. And then the amazing .NET framework just came to being, and then everybody was happy, and yeah, and Java started to lose market share. Now, the interesting part here is Microsoft have made a lot of bindings with .NET Framework. So, for example, you had the C# as a programming language, which probably like the main representative of .NET Framework. Like if you would like to work with .NET Framework, you use C#, right? And then they made the J#, which is Java, but interfacing with .NET Framework. And J# was, you could actually install it up until, I don't know, like what, 10 years ago or something like that, and they just simply kicked it out. You had F#, which is the functional programming language, but F# actually appeared much later in the game. What else? Visual Basic.NET for Visual Basic developers. And there were a lot of Visual Basic developers. So people who were only developing in Visual Basic, they just simply saying like, hey, we can right now do we can right now not do work with .NET Framework and Visual Basic. So just simply like move there. I cannot remember right now the rest of the programming language. Actually, there was even C++ CLI. But this was, but I don't know if it's still active though. I haven't actually looked at it right now. But there was actually a C++ binding with .NET Framework, and you can write .NET code with C++ and stuff like that. But I don't think it's around anymore. At least I don't hear about it in the medium. Maybe because I'm not following that part. But in any case, yeah, try to check it out and see. But in any case, right now, the main things, I mean, the main drivers or the main programming languages that you can find for .NET Framework are actually C# and Visual Basic.NET. And yeah, this is pretty much the history of how C# came to be. Now, of course, .NET Framework has its own history, which Dennis already have talked about, the .NET Standard and the .NET Framework and whatnot. But these evolutions right now, like, and I think .NET Framework 6 or 7 is coming up. Actually, 6 has been released. 7 is actually coming up, as far as I remember. So yeah, so this is like this part of the history is, let's say, is done. Just a nice story to have a background about, since you weren't probably around when this happened. Now, let's talk about how C# compiles the stuff. Now, as an engineer, I usually like to know the stuff inside out. I don't like to drop things and just like I don't like to learn the thing as is and leave it. I just like to know what is actually happening behind the scene. Because when you know the things inside out, you can start bend the stuff to bend whatever you want into your own will, and you know how to hack the system if you want to. So it is actually super important for you to understand how certain things work. What you see in front of you right now is like how your source code passes through any compiler, and I think it is the same thing for even C++ to a certain extent. So these are like, whenever you write a program, and I'm talking about the modern programming language, I'm not going to say that you are writing an assembly right now. Okay, so we are talking about C, C++, and C#. And this is closely resembling C# than anything else, and probably C++ as well. What happens here is your source code passes through several phases, which is the lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, then a code generator. And this is where the output of that code generator, it actually generates your assembly code. And I'm talking about the assembler language, not the assembly as in .NET Framework assembly, and we're going to talk about this later. And that assembler will actually run on your target platform. So if you are compiling if you're compiling a C# code for ARM, is going to be having a different assembly code than, for example, compiling for a desktop Intel or AMD, for example, right? So yeah, we're going to talk about this in a minute. So let's assume that you are actually having this line of code. So you say price equals to amount plus rate times 50. And 50 is actually an integer. Amount and rate are actually a floating point numbers or real numbers. If you're actually going to open a computer science book, they usually say real number rather than floating point number or something like that. So what it will do, it will actually produce a list of something which is called identifiers, the lexical analyzer. So it says, okay, the price is a variable, amount is a variable, rate is a variable, 50 is a constant, right? And it calls them, in fact, it calls them identifiers. You're gonna get them like IDs down deep in the compiler source code. And what happens is, we need to make sure that this code is actually valid, right? So the syntax analyzer breaks this into something which is called a syntax tree, which I'm going to show you in a minute, like how C# breaks your code into a syntax tree. And the interesting part here is actually, and also we're going to study trees in algorithms and data structures. So it's actually quite close to, you see how things are. Everything is connected. By the way, nothing is like separate. So if you learn how to make binary trees in C#, you will understand how to make a syntax analyzer like this one, how to break your this is such a line into a tree and make sure that it obeys a certain grammar. Now, every programming language has its own grammar, by the way. And I'm saying that because if you look at C# code and you look at Python code, they are not the same, right? And the same thing goes for, I don't know right now, Visual Basic or something like that. So each programming language has its own grammar, and the syntax analyzer, what it does, it just makes sure that everything obeys the grammar. And if you are actually obeying the grammar as it should be, that means you don't have a syntax error, right? Let's actually go forward. So it says, okay, you are actually writing the code according to the grammar. Let's actually right now analyze it. Are your types intact? So it says, okay, this guy is a float, this guy is a float, however, this guy is an integer. Can I convert this to an integer, right? Or sorry, to a float, sorry. So the 50 needs to be converted to a real number or to a float in order for this operation to be successful, right? So what it does, it tries to do that. If it cannot convert this, you're going to get an error. So here you're going to get, for example, a syntax error. Here you're going to get some sort of compilation failure error because it failed to convert a certain type to another type. You already can see that in C#. You will meet such a thing. Let's say if you try to convert a person class to an integer, right? Of course, you cannot translate it unless you explicitly say how to cast a type to another type. There is actually a way that you can write this code, by the way, that you can maybe I will show you in a future class, but just remind me, but not in this class because it's a little bit, you need to know C# first before we go with such a thing. But there is a way that you can say, I can cast a person to an integer. But you have to say what is going to be the output, and there has to be, of course, a reasoning why you would like to cast a person to an integer and back. But it's another story. So, and if this actually succeeds, then what it will happen, you get an intermediate code, and the code is like following whatever you have written in that syntax tree. So it says, okay, I'm going to convert the integer to a real number, so that 50 becomes float. And then I will multiply, I don't know, the third identifier here with the 50. And then once I'm done with that, I'm going to add the result. And then all this result is going to be assigned to ID 1, right? So you are just simply like currently we have this bottom-up approach, right? There are compilers who are actually doing the top-bottom approach, which is, again, another story, which is unrelated to us right now, but good to know. And then once you are done with that, we go here. Your code optimizer. Now, usually compilers are very, very good at optimizing code. Very good. So I highly doubt. Up until now, I haven't seen someone, or maybe there are rare occasions that you can actually write more optimized code than a compiler, but this is super, super rare that you could pull that off. But usually code optimizers just simply will like start to compress your code, minimize the number of instructions. And I have no idea why this appeared, but okay. Or why is there actually to begin with. But you need to, it actually like minimize the number of instructions needed for the CPU to actually execute a certain code. And the less the instructions actually, the less the instructions are, the faster your code will run because you don't need more CPU cycles to execute the code, right? Now, these stuff, worrying about how much cycles or how optimized your code is, you shouldn't be worrying about it, at least in this point. And unless you are working with real-time systems where you need super fast speeds, you need to do something which is called profiling first, which is again out of the scope of the subject, but I'm just giving you some keywords here. So code profiling, write it down somewhere, explore it on your own, check it out. But other than that, this is what happens once you actually just hit Control F5 or F5. You get an assembly code just runs on your CPU, and then boom, you get an output. Hopefully, if everything goes by the book. So this is how a compiler generally works, regardless of what it is. Okay. Now, actually, let's talk about in C# terms, right? What's actually happening here? So this what I've described right now is right here, is this little box. Okay. So your C# code with your resources gets crunched into that compiler. And I think maybe this class or the next class, I'm going to show you the C# compiler source code, and then we're going to show you how certain interesting things go, like within the compiler. But one of the phases of the C# compiler, which probably I haven't talked about in this diagram, the previous diagram, which is called lowering, like the code rewriter, the code optimizer, or I think it's called the code rewriter. Hang on, let's see, which one was it? Yeah, that intermediate code generator. It has a lowering, something which is called lowering in it. And lowering means that you can convert, for example, you know how to write a for loop, right? So you can write a for loop in a different way, isn't it? What will it be? If I ask you, say, do not use for loop, but you're gonna have to give me a loop, what are you gonna write this for loop in? How can you convert it to something else that loops?
There's a while loop and a do while loop.
Exactly. So you have a while loop. So what happens is your compiler will lower it. So your for loop is in fact is going to be a while loop. And actually your while loop will be converted to a goto statement. This is something which people who work with assembly can see it a lot. You can write goto statements as well in C#, but do not do that. Extremely bad idea, unless you are doing something super specific. But in any case, so that lowering part and everything just gets, like passed through, like, so your code just passes through all these code optimizations, trying to make your code run as fast as possible. And then it gets converted to an EXE or a DLL. It's called a managed code. It's called managed assembly for two reasons. One, it's actually compiled into something which is called intermediate language, or Microsoft Intermediate Language, so MSIL, and they call it assembly because it is the assembly code, which is the .NET framework will pick it up and start running it. The guy or the thing it's responsible to run your assembly code, this intermediate language code rather, which I'm going to show you in a minute, is called the Common Language Runtime, or the CLR. Now, the CLR has a bunch of stuff. It has like the security aspect of it, or the security component of it. So meaning that you cannot access one program cannot access the other program memory space, for example. So this kind of protection needed, unless you are a hacker who tries to crack a program and then you start to spy on somebody else's memory addresses. This is completely another topic. If you are interested in that topic, try to research about writing secured software. That's like completely different. It's a completely different world, by the way. And it's fun for those who love to try these stuff. It has the garbage collection, which will, how can I say, if you actually create a pointer, which you don't create pointer by hands unless you have an unsafe code, but which Dennis I think already have talked to you about. But if you write if you allocate a memory space for an object, let's say you are making an object of a student, once you are done with that, you don't need to deallocate that memory anymore. You have a garbage collector that it actually does the work for you, and it just simply said, oh, okay, you're not referencing that person anymore or that student anymore. It just dangling in the air. So just simply say like, okay, let's clear that from the memory. Now, garbage collector has several steps, like has several levels. And the deeper it goes, deeper a certain object goes in the garbage collector, the slower things get when it comes to cleaning up. But you don't feel that unless you will not worry about the garbage collector unless you are working either in games or you are working with high speed services that have a certain budget. So for example, it says, okay, if I search for an item in a product, let's say you're working in Amazon and you're trying to search for, and somebody searched for a product, you have to write a code to search for the product in a database and fetch it out. You have something which is called execution budget, and it will say, okay, a response of that search should come out in, for example, I don't know, like 16 milliseconds or 8 milliseconds or something like that. These crazy numbers. Right now, you need to start really looking out for how garbage collector works and knowing the internals. But again, I'm actually like throwing at you a bunch of keywords. Please take notes and research, learn more about this. And if you have any questions, of course, just feel free to ask and I will actually help you out with more details. So let's see. So yeah, the common language runtime will actually grab your intermediate language and it will just simply like execute stuff one by one, line by line. You have something which is called the JIT, which is just-in-time compiler, which is actually an interesting concept. So what it happens is, let's say that your program is, let's say, 10 megabytes, hypothetically speaking. There is no need to load this whole 10 megabytes and extract it in the RAM, practically speaking. What you can do is load just part of it, which you are just typically using. And if you're going to use a certain other functionality, I mean, the JIT compiler, what it will do, it will just simply like whatever is loaded is converted into a machine code and execute it on your CPU. If you trigger another functionality which wasn't loaded, it will actually fetch that, compile it into machine code, and then run it, right? And this is actually like more of a memory optimization and execution optimization as well. So your program runs a little bit faster because instead of loading the full program in the memory, you just simply like load just a part of it, which you actually need, and just simply like run the shit. And once the thing is running, it will just simply like convert it in a regular real assembly code and handle down to the operating system, which the operating system will take and handle all the instructions which has to send to the CPU, and then boom, you get your calculations or you get your program running. Okay. And by the way, this is I'm right now not talking I'm not talking in depth here. I'm just simply flying over certain concepts. So my advice to you is really like read about this and research about this. It's actually gonna get you a long way in understanding how actually computer works and how, at least in the case of C sharp, you will understand how C sharp works. Uh, I think this is it when it comes to the basics. So we got the history, we got how the compiler works, we got how C sharp works, in theory, let's say. And we can actually, I will actually give you like a break until 2 and 5, and then we will carry on with writing an actual C sharp code and show you how things are being decompiled. So we're going to decompile a C sharp code together and look at the IL and see all the other details of how that thing actually works. Before you go on to the break, do you have any questions? You can type, by the way, if you don't want to say something.
I don't think we do.
Okay, I assume that everything is clear. As a day, then I will actually see you after the break. So 2:05 then. All right. Time to get back to work. So, let's talk about, let me show you something fun first before we actually create a new project and we compile stuff. So if you are working with C#, you probably happen to see, you probably would have happened to see something like around, like, you would like to see maybe how things work internally, and you get the graphics out of it. Sharplab IO was used by the Roslyn compiler team. So the latest, before I forget, the latest, well, not the latest, but it was like this for how long? I cannot recall anymore. Like Roslyn compiler was Roslyn compiler open sourced. In like what, 5 years, 4 years? I really cannot recall anymore. And they were actually using this as a tool to test certain hypotheses or theories rather. So so this is actually an interesting tool you could actually have a look at. So if I actually put this under run, now obviously they left a simple code here. I'm gonna actually write something a little bit simple here. So namespace, namespace, my program. And right here, I'm gonna have a public class student maybe. Oh, actually, maybe we need a program first, so we can have a static void main. And we don't need the system arguments actually. Oh, sorry, habit of saving. And probably you can have a console.r, please. Man, I need to change the keyboard. This is gonna be let's say hello world. I'm gonna actually show you some fun stuff at the beginning just to warm up. A couple of things I actually use personally, like when I'm trying to test stuff. But this is one is good as this what I'm showing you right now is a good learning tool. And the cool thing about this is that this hash, which you see here in the address bar, is good for you to share code with someone. So if I actually copy paste this right now, you will get exactly the same thing, right? If I copy paste that link to you right now in the messages, you will get exactly the same code which is here. So so this actually runs quite fine. Now actually let's talk about how to utilize that thing. So if I actually have a public class, maybe student, and we have a public string name, which is a get and set, and this is called a property. We use in C# Pascal casing when naming stuff. And properties actually have an interesting story to them. C# 1.0, we weren't able to write properties like this. But in C# 2.0, I think automatic properties have resurfaced. And I'll show you what it means in a minute. But let's actually go down the road here. I'm going to say that this is int age. So I don't have a proper IDE to help me formatting this stuff, so I have to format it myself. And right now what I can do is I can create a new object of a student. So because if you don't actually specify a constructor is made for you, like by default. Why are you complaining though? Yeah, probably. Okay, now it caught up. Apparently just got stuck for some reason. So here is going to be a console. Actually, I'm going to have a var std, which is called implicit typing instead of explicit typing. Explicit will be this, and implicit will be this. Equals to new student, and we're going to discuss that later. And I can say std.name is going to equal to, for example, this, and std.age then equal to, I don't know, 100, and this is going to be our little secret. And I'm going to have actually inspect, and this is not built in C#. This is a tool coming with sharplab.io. So here it says inspect memory graph. So inspect dot memory graph, and then I pass to it the object, which says which object would you like to look at. So I'm going to say, please look at std. And there you go. This is how, hypothetically speaking, quote unquote, this is how things look like in memory. Okay. So first of all, we allocate a reference on the stack because the student is a reference type. Can you please just confirm here? Dennis discussed with you reference type versus value types, right? Anybody can write?
Reference types are on heap.
And value types are on stack.
Yeah.
Okay. At least this was discussed. All right. So the reference types are classes most of the time. And they are allocated on the heap, which the garbage collector looks at. And whatever is allocated on the stack they are called value types. And what happens is on the stack you get a pointer or a reference is pointing to a place in the memory or a place in the heap, which says, aha, here's the object student with a backing field, and it's actually a string. And a string actually is going to be like because a string is a class, is an actual reference type. It's going to be like referencing to like the other guy, like referencing to another place in the memory. Says, okay, this is the actual variable, and then age is going to be also in there. So everything is just on the heap right now, including the value type itself. So that's why usually we say, like, not necessarily all the time value types are actually on the stack, but if you define, for example, something like this, and you say int I equals to 10, and you say inspect.memory graph, and then you say I, right now you're going to definitely for sure get an actual I on the stack, 100%. But this is actually like, inside an object, boxed, we call it, inside an object, and it's actually being on the heap right now. So, and you see how beautifully it is, like this, how this tool, sharplab, is actually like pointing out and say, this is belonging to this, and this is belonging to that. And this variable is actually this guy. It's like with arrows and stuff. It's actually kind of fun tool, as I'm saying, for you to explore. I think if I actually say, instead of inspect graph and say inspect heap, you gonna get the actual like hexadecimal, like zeros and not zeros and ones is gonna be. It depends on actually which option do you select, but it takes a little bit of time. But until it actually runs, hopefully, you can actually use this tool in order just to see like what's actually allocating on stack on what's actually allocating on heap. You usually do not worry too much about it unless you are working with high performance computing. Right now, you really need to look out for these stuff. But other than that, this is actually a good learning tool for you as a student to understand, okay, this is allocating on the heap because of that, and this is allocating on the stack because of that. So this is how it looks like. So you have a header of the object itself, the type handle, which is describing which type of it is, which is currently a student, but it has this hexadecimal, I think, or decimal representation. Sorry, let's actually convert this to a hex, so it can be all fit in where. And then you can see here is simply like saying, okay, and this is like the name, the backing field name, and then the backing field age, right? And age is what we have in 32, so 4 bytes. Okay. And let's see, actually, char. So if we actually display this in characters, we should be able to see. Yeah, it doesn't expand. That sucks. Actually, we could have read. Let me see if I can actually pull this off right now. Let me take this out from here. Let me take this out from there. All right, doesn't matter. Because actually there is a you can possibly read. No, not here. There's a possibility that you can read Dennis actually right here. But it's but you have null terminating strings because string is actually array of characters, by the way, but it's another story. That's why I have this null terminating strings everywhere. Yeah, but I think this is pretty much it. So use this tool actually to explore things. It's actually kind of fun. But now, do you remember when I actually was talking about the syntax tree bit? It's actually here. So you can say, give me the syntax tree. And right now you're going to see how your actual program is being broken down. So, and it's actually being highlighted as well. So for example, you say, okay, this is the public keyword. And then you have the class keyword, the identifier token, because this is an actual program. You can call it even whatever. You can call this pair 3 if you want to, and it will work. That's why it's actually that's why it's called an identifier. It's gonna be it became an ID, if you remember from that image. The tokens are the programming constructs, let's say, and the rest is let's see, the keyword with the spaces in. Oh, by the way, these are called the trivias, which is something that the compiler says, yeah, like I think it's, let's say the trivias are the simplest elements of code that might or might not break the code. I know it's kind of weird, but definition, but it's actually very important to get. But in any case, I mean, if you're working with compilers, you will actually have to learn this in much deeper manner. I'm not going to discuss this here. Let's see. So if I actually go to, so this is actually a good point here. So you have the declarations, type variables. Like you can see here, it's literally like broken into a tree, and you can actually keep track of what has been allocated and how's been allocated, what are the symbols, and so on and so forth. It's actually fun to observe this and learn more how your code is actually being broken down. Now, if you would like to see IL, this is even more interesting stuff. This is the content of your exe file or DLL file. So if you actually grab your DLL or exe file that is coming out of Visual Studio in C#, it actually has, of course, if you open it in Notepad, you're going to get binary. But in fact, that binary thing is actually this. So this is being picked up by the CLR. And as you can see here, this is not an assembly code. This is intermediate language code. The assembly code will be handled by the common language runtime in order just to compile this into an assembly code that runs on your CPU. Now, there are actually books discussing this, and actually, depending on what applications you are working on, I have actually met people who have to look at this if they want to optimize their code even further. But you have to know C# inside out for that, and there are books on that on the topic of intermediate language and how it works and all that stuff. And this is actually like pretty much it. If you would like to, if you are having the habit of, like, say, right now you know that the C# code can be decompiled, I can actually point you to ILSpy. And there are many others actually, but ILSpy is actually quite famous. So let me bring it here. So if you actually go to releases, and there's actually a preview 8.0. Okay, they updated to the new C# and the new Roslyn compiler. Give me something stable. So I will actually grab the zip file if there was the binaries, because I don't want to install stuff. And if I actually extract that somewhere, so let's see. Oh, come on. Let's say I'm gonna create a new folder somewhere. Give me a minute. So this is ILSpy, and this is how you can take a program and decompile it. And once you decompile any C# program, you can decompile. Any C# or any .NET Framework DLL, you can actually decompile. Okay, to be precise, you can decompile anything, but the main thing here is depending on the decompiler, how much human readable the output is right now up to how good the decompiler is. But this is another story. In any case, let's see. So for example, this is the .NET Framework 4.0, let's say in my case here, and I can, let's see, system. Do I have anything interesting under system? I thought that system.io had the stream reader and stream writer under that. Is it? Well, let's see. Yeah, I cannot actually compile something interesting here right now. Let's see, what is this one? This was probably a leftover from somewhere. Okay, this was actually we're going to talk about async and somewhere at the end of the semester when we talk about multi-threading. But this is, for example, how your async code is actually like 2 lines or 3 lines of code is being decompiled into this. But this is another story. I don't want to scare you out. But let's see, playground. Is there something in playground? Student program. So the student program, it has an ID and it has probably a name backing field somewhere. And as you can see, it's compiler generated because we are using automatic properties. It's similar to this guy. This guy. So this is actually called automatic properties. Full properties I will show you in a minute. But if you would like to, you can actually leave this to the compiler, so the compiler will just simply unpack it. And in fact, it didn't unpack it completely until the end because these guys gets converted into an actual methods. But let's say this is going to be C#, IL. Let me see here. So this is the intermediate language of that code, similar to the code which we have written. It's actually still there since last year. I didn't erase that program. But here you go. This is how your IL will look like, for example, for that program. So you can actually grab practically any C# DLL, and you can just simply decompile it and look at the code. Whether it's legal or not, it's a completely another topic, but it is super important to understand that there is something like this. And it's also super important to understand that there is an area of study called writing a secured code, where you can learn how to protect yourself from people decompiling your code. It's called code obfuscation. Let me write this down for you. And there are tools for that as well. But it's actually important to know that there are that you know about these stuff. At least I think it's fun. So this is one way of observing how C# works, right? So you can actually write code in sharplab.io, and then you can send some small bits and pieces to people to play with. So if you are, as a student, you are sharing with another student, fellow student, some interesting concept, you can just write it down and, hey, run this, and it will run in the browser. Another way, when I'm personally testing stuff, I go to sometimes Visual Studio Code because making a Visual Studio project to test an idea is actually taking for me too long. So I can just simply run Visual Studio Code. If you install .NET Interactive, you can create a blank notebook, and hopefully it works. And I will actually grab C#. And the cool thing here is, again, it relies on Roslyn compiler. So if I have, for example, for I equals to 0 and I is less than 10, I plus plus. And then right here, I can say console.writeLine. Of course, I forgot to define the thing. It should be var I or int I, it doesn't matter. And right here, I can have, sorry about that. This was a mistake. I can write ni. And right now you get like 0 from 0 to 9, right? So this is one way of doing this, like testing ideas, right? You can actually write complete code with interfaces and classes and stuff, and you can play with that. And it's actually good to test things. There's also another way, which is actually quite fun. I think if I open Windows Terminal, Terminal. Now, Windows Terminal, for me, actually, if you are using the normal console, you can run something which is called the Developer PowerShell for Visual Studio 2020 or Developer Command Prompt for Visual Studio 2020. So if you 2022, so if you have installed Visual Studio, you should be having these options available, not only in Terminal but in general. Like you can search for them in your start, and what you can do, you can just simply type CSI. And right now you are running with the browser compiler. So what you can do is just console.writeLine. Okay, I'm gonna definitely change the keyboard. Hello world and enter. And right now you actually have the thing working. You can actually have a for loop. So I var I equals to 0. Honestly, I cannot remember the last time I written like multi-line code here. 10 I plus plus. I think it recognizes this, yeah. So you can say console.writeLine I, and then you can do that, right? So you can actually have fun with this in console if you needed to. The last one, which I can show you before we dive into an actual project, probably is called .NET Fiddle or something like that. And this guy is also interesting. You can actually write in code in the browser and it will execute it for you. So right now it's actually have this hello world. So if I surround this with another for loop of I, let's be int right now, I equals to 0 and I is less than 10 and I plus plus, you can just simply hit run and it will write hello world 10 times. Okay, so .NET Fiddle, SharpLab, this console, the CSI, in the developer console, Visual Studio Developer Console, and the Jupyter Notebook. This is the extension, .NET Interactive Notebooks. Is actually kind of fun to have around, and you can just simply like use it to test things without having the need to go ahead, like, you know, in Visual Studio, create a new C# project, right? So console app, .NET Framework, next. And right now you choose your .NET Framework and then you are off to go, right? So that's that. Now, first of all, let's actually have this pear-tree _ 2022, because we are actually in 2022 and we need to get in here so I can carry on with the subject. So I will actually close this. I don't need any of that stuff anymore. And we'll yank this out away. Before I carry on, are there any questions? Okay. I'll consider that as nope, and everything is top-notch clear. So let's talk about reference types and value types for a second. Let's actually rather reiterate over it. So if I actually have Okay, let it be internal. There's one thing I wanted to mention before I actually get into that stuff. Namespaces in C# are made for organizational purposes only. Let's for now we're gonna say it's only, okay? And you can think of it as organizing things into folders. So a folder under a folder under a folder. You can have several you can have nested namespaces if you want to. You can have another namespace which says trying things. Right? And you can put that in here. Now, this program will compile, by the way, but if you are actually smart about it, what you can do is just, instead of having this happening that way, you could just simply say this. Because what C# will do, it will actually treat it like, so if you actually put it like so, C# will treat it as if you have already done this, right? As if you have written two namespaces. So instead of you writing things nested in that way, just simply put a dot and you are good to go, right? This is why you can have something like these. Okay, so there's just simply having more depth. Now, this is, again, think of it like folders, like organizational structures, because system.collections, back then you had array lists, arrays, and other things that are not generic. And then when Microsoft introduced generics, which is, I think is called templates in C++, they had .generic, right? So that's why, as I said, it's just our organizational folder structure. Well, think of it that way. Namespaces in C++, they have a different meaning, obviously. But here in the C# world, it doesn't, other than just simply be organized. When a class is called internal, it means that it cannot be visible outside of that namespace. So anybody is referring to this class from outside of this namespace will not be able to see it because it's actually internal. If you make it public, it's going to be available publicly. If it is private, it's going to be only visible within the namespace. Internal, I think, is going to be always visible to the namespace and anything underneath it, I think. In any way, if nobody specified anything here, that means that this is by default is private. So if I actually omit this, the compiler will look at it as well as private. But in C#, we usually tend to write private because it's better readable and not that quite popular that you eliminate this. All right, so that's one out of the way. What else? Okay, so let's actually talk about the reference types and value types thing. So if you actually, oh yeah, right, the code complete is awesome. I'm gonna actually call this, I'll let it be ID, why not? And let it be name, why not? So let's say that this unit has an ID and a name, which is okay. If you don't define anything right now here, C# by default will generate for you a constructor. And if I will actually like start to use IL here just to prove my point. Let's see. But of course, IL works only with, let me remove this. Let me remove this. So we are good to working with a clean slate. And let me go here, open this in Explorer. And I will go into Ben debug. Okay, so right now I didn't compile that thing. So nothing is in here. And this is the console app. So if I say console.writeLine hello world. Do you know does anybody know the trivia of who the first actually said hello world? Anyone? Right now, just compiled. There you go. Do you know, guys? The first one who said hello world? Oh boy. It appeared actually in the C book. Hang on. The C programming language. It was the first one. This one, which coined the phrase flow world as an introduction. This is a famous book by Dennis Ritchie and Ken Thompson when they written that book, the C programming language. It's a classic. There we go. It's actually here. Obviously, it is super expensive for some reason, but I'm just gonna share the code, the thing. But in any case, going back to where we were. So if I actually expand this, right now we have the student, I think. So if I actually expand this namespace, I have the program and I have the student. And if I actually put this C# and I say, right now it is actually like 10.0, I would like to put it to 1.0, like the very first beginning. And apparently it doesn't actually unpack it nicely even. I cannot see the default constructor. However, you can actually see your properties are being actually generated. So let me show you this. Actually, C# will assume that you have it will give you immediately something which is called a default constructor. So if I actually hit the CTOR, right now this is called a default constructor. And if you don't mention it, the compiler will generate one for you. This is called an automatic property. Sometimes, in some cases, you can have a property. So you define something which is called a field. This is called field. And you can expose, actually, by the rules, underscore. And right here is going to be age. And then get return age, set return age. So there you go, value. This guy gets later converted into something which is called a getter and a setter, which comes from the Java days. So down deep in the compiler, you will see this public int. I think it's going to be get underscore age or something like that. And it's here is going to be saying return age somewhere deep down in the compiler. And then public void set underscore age is going to be something along the lines of, come on. Actually, here's going to be int value. And right here is going to be, let's call it age for now, so I will not confuse you, because value is a reserved keyword in this case. Here is reserved keyword. And you cannot actually change it. By the way, if you write anything else, it will just give you an error. So it's actually important because this guy apparently maps to this guy directly, but I'm just naming it here so I will not confuse you. And this is going to be like what? Underscore age equals to age. So this guy unpacks, or any property, any automatic property unpacks to this. Then later on, this unpacks to that. And this is called a getter, and this is called a setter. Okay? And you can see it in Java code everywhere because Java doesn't have something which is called properties, which is much, much cleaner code right now. Long time ago, actually with C# 1.0, when I started working with it, we didn't have automatic properties, so these guys never existed. In order for us to write properties, we had to write it this way. You will write full properties, which is called a full declaration property, if you need to do some interesting things here. So for example, let's say for a second here, that you would like to, all the time when somebody asks for the name of a student, you write it in high caps. So what you would do is something along the lines of this. So var std equals to new student. And we're going to talk about object initializers later, but if we say std equals to std.name equals to Dennis, for example, and you would like to console.writeLine std.name, right? If I actually hit Control F5 on this, you will get the name Dennis as it should be. But right now, I would like to make this high caps. So in order to do that, you can actually make a property, a full property out of this. So either I actually can write this in that way, or there is a neat trick actually for this one. So I can actually say prop full double tap. And when you say double tap, it just simply like immediately makes this one for you. So string, tab, tab, and then name, enter. And my property is going to be name. Sorry, this should have been underscore. Forgot. Okay. And this one is underscore, and this one is underscore. Now, here's the interesting part. You would like always to return it in high caps, right? So it's going to be a dot to upper. And it's a method actually within the string class. So if I hit actually Control F5 right now, you're going to get it always to upper. So this is one of the reasons why you would actually, one of the reasons why you would actually like have to say, okay, I would like to have a full property. Another reason maybe is that you never would like to write the age, for instance. So imagine this, somebody you would like to get the age of a person. You can actually have only a getter without a setter. So you don't need to set it anywhere. All what you need to do is just simply say, for example, but I'm going to write it in under comment here. You're going to say, for example, subtract current date from birth date. And right now, let me put this like so. And right now, for example, you could have, you could actually, instead of just return the age, you just simply return this calculation, right? And right now you get the age all the time calculated correctly. So this is one of the reasons why I would like to play with properties a little bit instead of just simply initializing them that way. During this class, you will not maybe use this that much, but in the exams or during a specific requests, maybe you will have to do this, or we're gonna have to do this at a certain point in time. So I'm actually showing this to you so you will not get surprised in case this happens. All right, so this is about properties and full properties. So let me Control KU this guy. And let's continue on. So if I actually have, because you cannot call a static method from a non-static method, that's why it has to be static, because I'm going to call it from main right here. If let's say I have a modify, public static void modify. And right here, I just simply say int I or a, will it be a? And I here just simply gonna say var int x equals to, why var int? Var x equals to 10. And you say modify, which Dennis already have showed you probably, something similar to that, modify x. I'm just gonna write here console.writeLine x, and I'm gonna, there are a couple of ways to concatenate strings. So if you would like to have, for example, say, you can add the plus sign, and then you can say value of x after modify equals to, you can do that. You can say a equals to 20, and then console.writeLine. The other way to do this is you put in the $sign, and then you can write in, I actually forgot the name of the interpolating strings. Yeah, it's called that way. So right now you can actually use interpolated strings. you put the curly braces, and we say A. However, in here, before that, we can say value of X after modify within, but from within modify equals 2, right? And I called it different names so we will not confuse each other here, but let's see. So if I had Control F5, so value of X after modify from within modify is 20. And then later on, the value of X after modify call is actually 10. Now, this actually tells you a very important concept, which you need to hammer down in your head because it's a cause of many, many bugs. The integers, all the primitive data types, integers, floats, I think decimals, what else? Anything that is actually a struct is a value type. And they cannot be modified by reference. You have ability to modify, to force that by calling the ref keyword, but the ref keyword and out keyword is going to be explained later on. But basically speaking, you are actually modifying a value type, and everything is copied by value. So this X is not the same as it here. It just got copied over. So you are not modifying the same memory address anymore. However, if I actually close this right now, and if I run, for example, say, okay, I will keep the student. I'm going to have private static void modify student, and I'm going to have a student std. I'm going to call this actually student. If you have noticed how I'm actually naming my variables, when you are, but according to the C# standard, you are using Pascal case with the name of the properties, name of functions, or methods rather. There's actually a difference between a method and a function, by the way, but I'll tell you in a minute. So a property and the method names are always using Pascal casing. Pascal casing means first capital and the second is capital. Camel casing is going to be the first letter is small of the first word, and then the next word is actually capital. So this is the camel case, this is Pascal case. In C#, the name of functions or methods and the name of properties are Pascal cased. The variables within the method definition is always camel case. So if I say here student of fit, this is how you would write it, right? So if you have multiple words, you just simply follow the camel case. The first letter is small, the rest is just being capitalized. So let me actually remove this. I just need to highlight that. Now, if I actually say here student after modify call, and I say here student.name equals to not Dennis anymore, but Mohammed, for instance, right? So here I can, so I've defined the name here, right? And I say modify student. Modify student is going to be std. And then I say console.rocketline std.name. Later on, we're going to talk about overrides. Dennis actually explained to you override to strings and stuff like that, right? People?
Yes, you explained it yesterday.
Okay, good. We're going to actually discuss this in a minute. And right now, because the student is actually a reference type, we should be able to see that the student name became Mohammed actually. So that's how you actually differentiate between a reference type and a value type. So if you modify an object by reference, apparently my Explorer crashed. So if you actually modify an object by reference, you have to be careful how you deal with this. This is why people are actually into functional programming and having immutable objects and stuff like that. So it's a completely different topic of software engineering. Now, there's also an interesting point to bring up, which is modifying arrays. A lot of people had problems with this, including myself. How can you make a copy of a list? And later on, we're going to talk about lists in the future. Because lists or arrays are reference types in C#. So if you actually make a copy of an array and you try to modify one, it will modify the other because you are making just a reference, so you are modifying the reference. So you need to serialize and deserialize stuff in the memory in order to force make a copy. So it's actually an interesting, you run into interesting problems if you don't know how to deal with reference types at the end. All right, so that's one piece. So we have the reference types, value types. Let's talk about the overrides. So if I actually save this and compile this one more, and if I go here and I say reload, I think if I actually look at the student itself, you see the base type is coming from an object, system.object. And if you look at system.object, we get virtual functions. And I think you have seen already virtual functions or virtual methods in C++. Have you? Right? I think C++ has virtual methods. I think. Is it?
Yes, yes.
Okay. So, okay. So first of all, before I carry on, let me tell you what is the difference between a function and a method. Now, in C# world, there is no such thing as a function. It's only methods. Okay. A function is, well, a function is a function if it doesn't live inside a class. Everything in C# is a struct or a class. There's no such a thing. You cannot actually write, as you can see here, you have a class program, right? And then the void main. You cannot actually execute something without having the program and the main. And main in this case is not a function, it's actually a method. Okay, and it's a static because the compiler needs to say program run. So let's say it's run.program.main, right? So it calls this statically. Now here's the interesting part. If you are actually using Roslyn compiler and to do all these sorts of stuff, there is a whole code that's generated for you to hide this fact. You saw me in Visual Studio Code. I'm just writing calls to executing code without static void main. And this is because the Roslyn compiler has a part of it that it just simply generates a lot of code for me. But other than that, there's no such thing as functions in C#. There's only methods. And you're going to see, if you look at the book in C#, you will see a lot of them. They are just simply saying methods, not functions. However, people lately are using it interchangeably. Because not being super accurate is, and everybody knows that there is no such a thing as a function, so people interchangeably use it. However, if you hear people talking about a method, that means that it's actually an actual, function, but within a class. In C++, you can write a function without a class. You can run an application without a class. You write in your you're using, and then you just simply have a static void main or something like that, or static int main, and then you can write in your code, right? And it will run. But in C# you can't. So that's actually the difference. Now, if we look back here, the object class is this hidden class that every C# class inherits from. Anything that you create, anything that exists in the .NET world inherits from the object class. And from there, you get actually three methods that you can override because they are virtual: the toString, the equals, and the other equals. reference equals, which is actually good to have, but this is another, it just makes sure that you have two references are the same. Get hash code, super important to get right. Get type, this is used for reflection, because you can actually write code that you can inspect other types. It's advanced right now in the advanced C# realm. Maybe you will see this in ERIS-2, I think, when people talking about dependency injections. But in any case, so yeah, you have these things that you actually can override. Actually, you cannot override this guy. Obviously, you cannot. But you can override all these guys. Now, get hash code is actually interesting because it tells you whether a certain object is the same reference or not. So if I actually have var std2 equals to new student, and if I actually say, okay, for the fun of it, std2.name equals to Mohammed, for example, let's actually remove all this under comment maybe. Console.write line, and then you can say std.get hash code. And this is for std, and this is for std2. And we should be having two different hash codes, and this is per object. There is an actual Stack Overflow post somewhere. I keep forgetting it, and I always Google for it until I find it. How to make how to override get hash code good in a better way that you don't have collisions, that you will never have. Not will never, but there's a very low chance that you get a hash code identical with two objects, even though they are actually different. Hashing functions, we're going to study about them in algorithms and data structures, by the way. So again, as you can see, everything is connected. Now here's the interesting part. If you would like to see the effects of this, if I say for a minute here that std equals to std2, you will see that we're going to get identical hashes because both of them are pointing to the same object. So, so yeah, and actually, if I'm not mistaken, this guy will be garbage collected because nobody is referencing to this object anymore. But again, we will not think about garbage collection. It's a completely different story. But in any case, right now you can see how the effects of Git hash code, what kind of things it does. Actually, I remember clearly I had a problem. I had a bug, a weird bug, with while working on a game. There was a memory leak somewhere, actually on a certain platform. And the fun part was actually it was a bug in the Unity engine. And the interesting part here is the only way that I could detect, because I didn't understand the behavior of what's happening in the program, the only way that I could detect this was that I found out that the hash codes of objects that are not actually matching as they should. And this was the only way to rescue me, to be honest, like finding because I saw that the references are wrong. I knew about it, but I didn't know how to confirm it correctly. And the only way that I could confirm correctly is this get hash code. But I had to override it, and I found that Stack Overflow post. Every time I forget it, and every time I have to implement it by hand and find that post again. Probably I need to keep it somewhere. But in any case, this is very, very useful tool. Now that we know actually the reference types and the value types, we know that we can actually modify stuff by reference. Let me see. Yeah, one more thing before I actually let you go then. If you would like to have something that it's actually a value type, you need something which is called a struct. And a struct will be something like a vector, for example, 3D. And then you're going to have a public int x and public int y and public int z, which is, okay, let's actually modify this. It's going to be float. I think it's much better that way. Now, actually, you can say float 3df, but who cares? And because you could have integer vectors and stuff like that. And this is actually quite interesting. This one is actually going to be allocated on the stack right now. And this is how you could create your own value types that can actually be modified by value. So this is, if you would like to have value types, you just create a struct out of them. If you'd like to have a reference type, you can just simply create a class out of it. Later on, we're going to actually see more of this in the future, like using structs and classes in later down the road. But I think this is pretty much it, other than more tricks that you would like to know about. Let's say, for example, setting the console color. As far as I remember, it was background color, and then you can say console color dot pine green. Let's see how it will look like. And yeah, it's the background color. Hang on, it should be the foreground. Now, the interesting part here is it's actually a state machine, sort of. If you set the state once, everything will follow. And you need to change the state if you would like to have something different. So, for example, this is going to be red. And if I hit this, so right now you see, even press any key to continue is becoming red because you set the state of the console to be that way. And what you could do is console dot foreground color equals to console color dot white, I think. And then if I hit Control F5, everything is quote unquote back to normal. So you can actually do all sorts of interesting things, type interesting characters, Unicode characters. You can actually, like, I would even advise that you can like just hit the dot. I mean, here you go. You can even make a beep, but I don't think, is it? I don't know if it can be transferred. Did you hear the beep?
No.
Okay, so it's actually not transferable. But you can actually play with that if you would like to bother the users. What else? That could be actually interesting. Yeah, play with the cursor if you would like to move the cursors. I don't think that there is something that is more interesting than, for example, like read an input, read line, or read a key or something like that. You can actually change the title, which is also interesting, the width and the height and stuff like that. But other than that, I'm going to actually show you later on how to have a Windows application and a console application at the same time so you can debug stuff. But that's also, again, another lesson. Let me check my notes here. If there are any other interesting tips and tricks. So I've already showed you some tool sets like the IL to CPP. Oh, sorry, not IL to CPP, IL Spy. I've shown you actually how to run code in Visual Studio Code, online, Shop Lab. The reference type and value type thing, we're going to actually practice even more. Next class, when I'm going to actually be having regular students in my classroom, I'm going to give you actually tasks to implement. So my advice to you right now, after this class or during the weekend, please try this at home because this is going to be published anyway on YouTube and you can actually try this, but try at home, work, and if you have any questions, feel free to send me over Microsoft Teams. I'm happy to help you out and will happily share screen with you and solve problems with you. So that's the thing. Okay. Any questions?
Could you just show us how to reference a class library? I mean,
Reference a class library like a DLL.
Yeah, because for some reason it's crashing for me. I don't know if it's the Visual Studio, but I don't know. It doesn't want to reference.
The problem is I don't know how do you reference, like, did you create actually a
Yes. We created a class library.
create a new project, so, and then you can have a class library. This is how to build the DLL. Did Dennis actually show you that, guys?
Yes.
Oh, okay, cool. There you go. Let me show you that one as well. Because I'm a game developer, probably I'm going to have this like something like math tools or something like that. And right here, it creates me this guy. So I'm going to have a vector, I'm going to have a struct, and then we're going to have this one, and then we're going to have a float x. There you go. There we go. Come on. Be good. Okay. All right. So here's the struct, and this guy has to be vector 3. And if I actually go to references, add reference, and under projects, you have the math tools. You just simply select it, and you hit OK. Now, if you try to reference from here to here, like add a reference, and then you try to do this, it will tell you are having a circular reference, which you cannot have. So, so probably this is the error, maybe. And right here, I can actually, do I have vector? Nope. Here you should say using math tools. And right now I can have var v equals to new vector 3. There we go. And then you can write your own vx equals to 10 f and v dot y equals to 12.5 f and v dot z equals to 13.54 f. There we go. And for a good measure, we can console foreground close to that color dot blue, since we are already in the RGB space apparently. Console dot right line, and then we have what vector, and it's gonna let's see, v dot x comma. I should have overridden this to string, to be honest. How about this? Let's actually do it as an exercise while we are at it. So I think we have override to string, and then we can say return this dot x. Oh, sorry. This dot x, comma, this dot. I need to write this. This dot y, comma, this dot z. And there we go. You could also overwrite hash code to make it even better, but there we go. And then right here, I'm going to just simply say, please write me v. And Control F5. So there you go. Here's your vector, right? Which is going to be probably, it'll be something like a cyan, something that hurts the eye. There we go. Good?
Yes.
Okay. So let's actually have a look at this one before I wrap up. If I actually open this is a whole different project, by the way. And if you go to bin debug, you're going to get the DLL. The interesting part here is because I referenced this here, you have to have the DLL beside the actual exe file. And if I actually decompile this, because this is a DLL, let me just collapse this guy. Come on, collapse. Collapse. And collapse. And collapse, reload. And I can actually grab that DLL wherever it was. Now the math tools is actually a DLL which has the vector 3 in it. So right now we could decompile the DLL, read the stuff. Right now you literally can see anything that's written in C# in ILSpy, actually. There's also an interesting tool from JetBrains. It's called .peek. It's actually for free as well. And it's literally, you need to name it like, hang on, let's see, where is it? Let me grab that tab right here. So there you go, .peek. There's also an interesting C# decompiler, and it is for free. And we have actually JetBrains account with faculty's email. So if you are using EduFeedback email, you can actually register and get the whole tool sets from JetBrains for free, which is freaking awesome. Adil actually worked on this really hard, which is excellent job from his side. So here's the .peek. Let me actually share with you the other links really quick. So let me see, where was the sharp lab.io? So I'm gonna actually share with you that link, rather in the, probably in the run state or something. So there you go. I'm sharing that too. What else? Right now for the Visual Studio code thing, if you would like to play with that, I think you need to look at Visual Studio Code. Oh, not you. VS Code. What was the name thing? There you go. It's called VS Code. So you have .NET Interactive Notebooks. So this one is the plugin which I was using. I don't care about this guy. And you have the other one, which is fun to have, so terminal. And right here you have developer PowerShell for VS22. So developer PowerShell for VS 2022. You seek that in your program files, or like it's here. You can say, I think it's called developer PowerShell. There you go. You see it's there. But I'm using Windows Terminal, and the Windows Terminal allows me to do all sorts of stuff. It will not look like this for you because I've installed something which is called All My Posh. It's an interesting extension for Windows Terminal that allows me to see stuff for Git and other things. But yeah, probably you might need to check that out. It's right there. It's actually, so this is the website. It allows you to create interesting things like so. There is a YouTube tutorial somewhere as well, if you are lazy to read. So yeah, these are the tool sets. I hope that I didn't miss anything. And if I miss anything, you're gonna learn about it next class. All right, I'll stop recording here.